Hello everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. Alongside the weapons that we have previously covered, Vampire Survivors also features a wide range of passive items for the player to choose from. These items offer valuable boosts in relevant stats, allowing the players to create diverse gameplay builds that cater to their individual preferences by mixing passive items and weapons. So working in tandem with the weapons, the passive items give players the freedom to mix and match different builds. This also boosts the replay value of the game, as the players can choose to go a different route when selecting their weapons and passive items each time, which results in a different gameplay experience. In addition to this, Vampire Survivors also allows for the upgrading of both the weapons and passive items as the characters level up. This feature grants the players the added power they need to overcome the game's increasingly challenging enemies, such as the bosses or the enemies in the later waves. So in this part, we'll explore how to create the different passive items and an inventory system to manage and store both the weapons and passive items. So this will also include a way for the weapons and passive items to level up. And by the end of this part, you should have something like this. Which is passive items, an inventory system to store both the weapons and passive items, as you can see, a way to level up both the weapons and passive items, and last but not least, an inventory UI to display the equipped weapons and passive items. And without further ado, let's begin. So before we truly start, it's important to address an issue that may have been causing some frustration for some of you. When stopping play in the game scene, you'll notice an error message showing up. Some of you may already know what is triggering this, but for those who don't, this is just triggered by our drop rate manager on the prop set enemies in the game scene. As you can see here, the error message asks if we are spawning the items from OnDestroy, which we are. But why does this trigger an error message, you may wonder? Well, as it turns out, Unity game objects can be destroyed in three ways: via code using the destroy method, unloading a scene, or exiting play mode in the editor. Now, the third is the culprit in this case, but do not worry, there is a simple solution to get rid of this error. So as pointed out by one of our supporters, Jamie, they actually suggested adding a piece of code to the top of the onDestroy method in the drop rate manager to remove this error. So a big thank you to them for that. All we have to do is open our drop rate manager and inside the onDestroy method add this code snippet. This piece of code will just simply check if the current scene is loaded when onDestroy calls, ensuring that the function only runs when the current scene is loaded, which means that it's running in the editor, and returns if it is not, thus eliminating the annoying error message. Now do make sure to head back into the editor and test the solution before moving on to the next section. Now that we have covered the error message issue, we can finally dive into creating passive items. Now, in line with Vampire Survivors, our aim is just to provide the players with an extra boost to their stats by equipping these passive items. Fortunately, the process is fairly straightforward since we have already laid the groundwork with our weapon and stat system. First things first, let's create a class structure. We'll start by making a new folder under scripts and name it passive items. And inside this folder, we'll create two new C# scripts called passive item and passive item scriptable object. The former will serve as a base script for our passive items, just like the base scripts that we created for our weapons, and meanwhile the latter will store the data for our passive items, similar to the weapon scriptable object and the character scriptable object. Inside the passive item scriptable object script, we just need to do a couple of things. Firstly, change the derived class from monoBehavior to scriptable object. And next, we need to define a new float called multiplier and create a property for it, similar to how we created properties for our player and weapon stats. Now, as the name implies, this float will serve as a modifier for the chosen stat. And lastly, we need to create an asset menu similar to the one we made in our other scriptable object scripts. This will allow us to create new passive items easily and efficiently. With the groundwork laid out, let's move on to implementing the passive items themselves. Let's open up the passive item script. Our first step will be to create a protected reference to the player stats, which will allow all passive items to modify the player's stats. You might remember from part 5 that we previously created modifiers for the player stats, such as might, which modifies the damage of attacks, and projectile speed, which modifies the movement speed of all projectiles. That's why I mentioned at the start that we're kind of already ahead of the game. Next, we need to create a reference to the passive item scriptable object, which will give us access to the value that we want to multiply the stat by. While we could store this as a public variable within the script, for consistency's sake, since our weapon and player stats are already stored in a scriptable object, we'll keep it in a scriptable object as well. Now, let's create a new function called apply modifier marked as both protected and virtual. This function will be where we apply the modifier within the individual passive item scripts. And also don't forget to call this function in start, so that the multiplier is applied immediately. Let's create our first passive item now, which will be modeled after the wings from Vampire Survivors, which increases the player's movement speed. To start, create a new C# script in the passive item script folder and name it wings passive item. Here, we'll do several things. Firstly, inherit from the passive item base class. Next, override the apply modifier function that we created previously. Then, using a simple formula, we'll multiply the player's current move speed by a multiplier value provided by the associated passive item scriptable object. As you can see, this formula is used to modify the player's current move speed by a certain multiplier based on the value of, well, the multiplier. Now to break it down, the formula works as follows. First, the multiplier is converted from a percentage to a decimal fraction by dividing it by 100 float. Next, this fraction is added to 1 to obtain the total multiplier to be applied to the player's move speed. Finally, the player's current move speed is multiplied by the total multiplier, updating their move speed accordingly. For example, if the multiplier is set to 50, the formula would just calculate the total multiplier as 1 plus 0.5, which equals to 1.5. This means that the player's current move speed will be increased by 50% since it's being multiplied by 1.5. Now, it's important to note that while we are using a multiplier, you're free to also increase the stat by a fixed amount if you prefer. However, for the purposes of our implementation, the multiplier approach is consistent with Vampire Survivors and feels more natural in games. Now head back into the editor and create a new empty game object under the player and name it wings. add the Wings passive item script to the object. And in the executable objects folder, create a new subfolder called passive items. And create a new passive item scriptable object called Wings passive item. Next, set the multiplier to your desired value, and for me it will be 50 since I want a 150% boost. And afterwards, add the Wings passive item to the Wings passive item script. One final step before we test the change. Head into the player stats script and remove the hiding inspector attribute from the current move speed field so that we can see the effects of the Wings passive item in game. Once you've completed these steps, we are ready to test out our first passive item. To do so, start the game from the menu scene and check the inspector to see that your player speed has increased by 50%, or whichever value you set for the multiplier. Now, for example, if your original speed was 5 like mine, it should now be 7.5, and as you move around, you should feel the difference in speed. To recap, the passive item modifies the player stats by the multiplier set in the start function. These updated stats are then used by other scripts such as player movement for movement speed in this case. And once you've confirmed that your passive item is working correctly, you can add back the hide in inspector attribute to the current move speed variable in the player stats script. Great, we've made our first passive item. For our second passive item, let's replicate the spinach from Vampire Survivors, which increases the might stat, and therefore all damage dealt by attacks. Now just a heads up before we get into this subsection, I'll only be covering 2 passive items to showcase the concept behind them. However, do feel free to just add as many as you like. To create the new item, follow the same steps as before and create a new C# script called spinach passive item. This time, instead of modifying the player speed, you'll modify the might stat. However, we're not done. Unlike the wings, we need to do a little more implementation to make sure everything works. First, head into your projectile weapon behavior script and create a method called getCurrentDamage that just returns a float value. In this method, simply return the value of current damage multiplied by the current might value. Now, replace all instances of dealing damage with current damage with getCurrentDamage. This ensures that the damage dealt is always up to date. To give you an example, let's say your player has a might stat of 1 at the start of the game. And let's say your multiplier is, well, 50%. If we take into account the multiplier applied by the spinach, the player's might should now be 1.5. By multiplying the current damage of the weapon with 1.5, we get a 150% increase in damage dealt. It's that simple. Next, let's apply the same changes for the melee weapon behavior script. Okay, so we're not quite finished yet. As you may recall, we previously also overrode the onTriggerEnter2D function in the garlic behavior script to implement the damage dealing functionality. So in order to make sure that the damage is being calculated correctly, we also need to use the getCurrentDamage within that script. Additionally, let's make the current might variable public so that we can view it in the inspector. Now, let's return to the editor. Create a new passive item scriptable object called spinach passive item and set the multiplier to 100 to double all damage. Next, add an empty game object to the player and name it spinach. Attach the spinach passive item script to it and assign the executable object to the appropriate slot. Before I begin testing, it's important to set both character smite values to their scriptable objects to 1. Leaving them at 0 will just result in all calculations being multiplied by 0 and, well, everything else will just be 0. Now, let's test our changes. Currently, both the weapons deal 5 damage and the enemies have 10 health. So if everything is working correctly, the enemy should now be defeated within a single hit since our multiplier is set to 100%, which makes it 200% damage. Launch the game from the menu scene and you should now observe the might stat in the inspector being multiplied, resulting in all enemies being defeated in a single hit. Awesome! And once you're finished testing, feel free to add back the hide in inspector attribute to the current might. Now before we end off this section, let's also make both our passive items prefabs. To do so, simply create a new subfolder under prefabs called passive items and drag both the wings and spinach items inside. And then we can delete the existing ones in the scene. Great! Now that we're finished creating our passive items, we can finally get into the crucial section of this part, which is the creation of the inventory system. Now, before diving into the details, let me clarify that when I say inventory, I'm not referring to a system where the player collects items with their backpack, as Vampire Survivors doesn't have such a feature. Instead, the inventory refers to a way to store and manage the different weapons and passive items that the player acquires throughout the game. As usual, we will start by analyzing what Vampire Survivors has done for their inventory system. But before that, I just want to preface that there are many ways to create an inventory system, so if our approach doesn't suit your preferences, feel free to implement something else. Okay, with that being said, in Vampire Survivors, the inventory serves as a way for the player to track their equipped weapons and passive items. Thus, our main goal is, well, straightforward. We need to create a system that will manage the player's weapons and passive items. We'll begin by constructing a script to serve as the inventory itself. Let's call the script Inventory Manager and place it under the Player Scripts folder. Inside this script, we need to define a few things. First, we'll create two lists, weapon slots and passive item slots, which will hold the player's weapons and passive items respectively. We'll initialize this list to have 6 slots each, as Vampire Survivors also has a maximum of 6 for both, but you can just adjust this number as desired. Next, we'll create two arrays called weapon levels and passive item levels to store the levels of the weapons and passive items. We'll initialize these arrays to 6 as well. Now we're using arrays to store the values of levels instead of lists because they are more efficient when it comes to storing a collection of numbers. Some of you may have noticed that we could have also used a dictionary to store the weapons and levels, as well as the passive items and their levels. However, since Unity doesn't actually show dictionaries in the inspector by default, and you need to use like a custom inspector to do so, using a list and an array would be more convenient for visualization and testing purposes. Now, let's create a method to add a weapon or passive item to a slot. We'll start first with the add weapon method, which takes in an int called slot index and a weapon controller called weapon as arguments. Now the purpose of this method is to assign the specified weapon to the given slot index. This will come in handy later down the line when we implement features such as the level up feature for the weapons and passive items. We'll also create a similar method for adding passive items called addPassiveItem. In addition, we'll create two empty methods, level up weapon and level up passive item, each with an int argument called slot index as well. Now these methods will be used to implement a leveling system for the weapons and passive items later on. And yep, that's it. That's all we need for the inventory manager for now. Let's now begin to implement the inventory, starting with the weapons. Starting off, if you recall back to a previous part, we actually created a list of game objects called spawn weapons inside the player stats that we use to track the spawn weapons. However, since we now have the inventory, we no longer need that, and thus we can go into the player stats script and remove those lines. Now we can begin weaving the two scripts together. We can start by creating a few fields. First, create a reference to the inventory manager in the player stats script called inventory. Now next, create two public integers called weapon index and passive item index. These variables keep track of the index for the weapons and passive item slots respectively. We'll pass these variables into the add weapon and the add passive item methods we created previously in the inventory manager script. Now be sure to assign the reference in the awake method instead of start, and make sure it's before the line that calls the spawning of the starting weapon. Now this is very important because we need the reference beforehand, otherwise it will cause a null reference exception. Within the spawn weapon method, use the reference of the inventory manager to call the add weapon function and pass in the weapon index and the spawn weapons weapon controller. Then increment the weapon index. This ensures that each weapon is assigned to a different slot in the weapon slots list and prevents overlapping. It's worth noting why we increment the weapon index after adding a weapon to the inventory. Consider an example where the player has two weapons. Each weapon needs to be assigned to a different slot. When the first weapon is added, the weapon index is 0 and the weapon is assigned to the 0th element of the weapon slots list. Now since that slot is now taken up by the first weapon, we increment the weapon index to 1 so that the second weapon can be assigned to the first element. Now we cannot increment the weapon index before adding the weapon because that will assign the first weapon to the first element, which is undesirable because the list and array start from 0, as you recall. Let's also add a safeguard to prevent any potential index out of range exceptions that could occur if the weapon slots are already full. Now to achieve this, we can simply check if the weapon index is greater than or equal to weaponslots.count minus 1. Now if this condition is true, we can display an error message using the debug.log error and return from the function. Now, let's test our script. To do so, we need to add the inventory manager script to the play object in the editor. However, before running the game, we must first address an important issue. If you look at the inventory manager in the inspector, you'll notice that the weapon slots and passive item slots lists are currently empty despite the weapon levels and passive item levels arrays being already pre-populated. If we run the game in this state, we'll receive the error message indicating that the list is already full that we created previously. But why is this happening, you may ask? Well, when you initialize a list in C#, it doesn't actually allocate memory for the specified capacity until you add items to the list. So although we specify an initial capacity of 6 when creating the list, they're still empty until we add elements to them. In contrast, when you initialize an array in C#, it allocates the specified amount of memory up front, which is why an array with a length of 6 will have 6 elements initialized to their default values that can't be removed. To fix this, we simply add these 6 elements to each list in the inspector. Alternatively, you can also use a loop to pre-populate the list, but that's not necessary in this case. After making this fix, we can run the game from the menu scene. If we pause and check the inspector, we should see our selected weapon in the first weapon slot. To test this system with multiple weapons, we will need to add some testing functionality to the player stats script as well. By adding the functionality to spawn a second weapon, we can now test our system with multiple weapons. To do this, simply assign a different weapon controller to be used as the second weapon in the game scene. For example, I'll set mine to be the garlic using the knife character in the play mode so that we have 2 different weapons. And after making the necessary changes, hit play from the menu scene. And if you now look at the inspector, you should see that both weapons are in their respective weapon slots. Great! Don't forget to remove the testing code once you verify that the system works with multiple weapons. And with that, we're ready to move on to the next step. Okay, so now let's start implementing the inventory for the passive items, which will follow the same principles as the weapon inventory with a few adjustments. First, we'll create a spawn passive item method in the player stat script to spawn a passive item of our choice, similar to how we have a spawn weapon method for weapons. Now to test this new functionality, we'll create 2 new game object fields for the passive item test and spawn them in the awake method. Now, in the game scene, add their prefabs to the slots that we just created for testing. And after that, play the game from the menu scene and you should see that both passive items show up in their respective slots depending on which one was spawned first. Move around a bit to confirm that the effects of the passive items still apply. Fantastic! We have successfully implemented the inventory for the passive item slots. We can leave the lines we use for testing as we may need it later. I have also realized that in addition to this, we can also add back the testing lines that we use to test a second weapon. We will need this for some time, so don't worry about removing them. head back into your editor and be sure to set the second weapon field before you move on to the next section. Now that we have our inventory set up with the weapons and passive item slots, we can begin implementing upgrades or levels for them. However, before we start, we need to fulfill a few prerequisites. Firstly, we need to add a level stat for our weapons and passive items in their respective scriptable object scripts. Additionally, we also need to add a field called next level prefab that will house the upgraded version of the current weapon / passive item, and this prefab will be used later on. Now, to explain how we will use the level stat, it is just going to be a way to keep track of the level of a weapon / passive item, and it's not meant to be modified during gameplay, so this is very important. So once we have added the level stat to our weapons and passive items, we can link it to our inventory. To do this, we simply assign the value of the weapon or passive item level to the slot index element of the weapon levels / passive item levels list within the add weapon or the add passive item methods in the inventory manager. To test if this works, make sure to set all the level fields for each of the weapon and passive item in their scriptable object before starting the game. So let's just set all of this to level 1 and start playing. And now when you pause the game and look at the inspector, you should now see that both the weapon levels and passive item levels arrays have been filled in correspondence to their weapon and passive item slots. So now that we have finished establishing the foundation, let's delve into the meat of this section, which involves implementing the level up functionality. To begin with, let's understand the approach that we plan to take. Essentially, we will be spawning an upgraded version of the current weapon / passive item using the next level prefab assigned to the current weapon / passive item. Next, we will assign the new weapon or passive item to the corresponding slot while simultaneously destroying the old one. This gives the impression or the illusion that the weapon / passive item has leveled up. You may wonder why we chose this method instead of replacing the data or the scriptable object for the weapons and passive items. Well, the reason for this is pretty simple. If you recall, our previous systems we have implemented for the weapons and passive items has quite a lot of stats and other data that would be difficult to manage. So replacing them could easily result in the game breaking down due to the misallocation of variables. Thus, by creating a clean slate with a new instance, we can just avoid this issue overall, although it may be more processing intensive. Now, let's move on to the level up weapon method in the inventory manager. First, check if the inventory contains a weapon in the specified slot index using the count property of the weapon slots list. If there is no weapon, we should not proceed with the rest of the method to avoid out of bounds error. Now, if there is a weapon in the specified slot index, let's retrieve the weapon controller script attached to the weapon game object and store it in a local variable named weapon for reference. We can then instantiate the next level of the weapon using the next level prefab field of the current weapon. And afterwards, the instantiated game object will also be stored in a local variable named upgraded weapon, which is then set as a child using the setParent method. If you find this familiar, well, that's because it is. This is how we spawn the weapons and passive items inside the player stat script. Alright, next, the upgraded weapon is then added to the inventory in the same slot as the previous weapon using the add weapon method. The previous weapon is then destroyed to remove it from the scene to prevent any overlapping. And next, the level of the weapon in the specified slot index is then updated in the weapon levels array using the level property of the upgraded weapon. And finally, let's repeat this process for the passive items as well. You may be still wondering why we didn't use the spawn weapon or the spawn passive item methods when spawning the new level / passive item. Well, those methods are specifically used to spawn the initial weapon / passive item at level 1, while the level up process actually requires a separate method for clarity. So although we could combine them into a single method, separating them is better and preferable for better organization. Moving on to the next section, we will be testing the leveling system, which requires several setup steps. That's why I dedicated it to a separate section. First, we'll create upgraded variations of our weapons and passive items, starting with the weapons. So in the scriptable objects weapons folder, let's create two new subfolders called garlic weapon and knife weapon. Drag the weapons into their respective folders to keep our project organized. Next, let's duplicate the garlic and knife weapon scriptable objects and add a level 2 to their names to differentiate them. We'll then make some changes to their data. For the knife weapon level 2, let's set the speed to 15 and the level to 2. And as for the garlic weapon level 2, let's decrease the cooldown duration to 2.5 and set the level to 2 as well. Afterwards, in prefabs, weapons, and the controller folder, let's create new subfolders called garlic weapon and knife weapon. Then let's duplicate the weapons and also add a level 2 to their names. Assign the correct weapon data to each prefab. Now do the exact same for the garlic and the knife weapon inside of the non-controller folder of the weapon prefabs as well. Also, if you haven't noticed already, this setup actually allows for future changes to visuals in the later levels, in case you would like to make any changes visually down the line for the different levels. Now let's repeat the same process for the passive items. In Scriptable Objects Passive Items folder, create two new subfolders called Spinach Passive Item and Wings Passive Item. Duplicate both passive items and add the level 2 to their names and update the passive items data. For the Spinach passive item level 2, set the multiplier to 150 and the level to 2. And similarly, for the Wings passive item level 2, set the multiplier to 75 and the level to 2. Now, in the Prefabs Passive Items folder, create two new subfolders called Spinach Passive Item and Wings Passive Item. Duplicate the passive items and add level 2 to their names as well. Then, assign the correct passive item data to each prefab. Before we forget, let's fill in the next level prefab fields for both weapons and passive items. Since we don't have any level 3 items yet, we only need to fill them for level 2. For weapons, be sure to fill them in with their respective controllers, so not the object itself, the controllers. I think it's also a good time to emphasize the importance of remembering to set the level and next level prefab for each scriptable object when creating a new weapon or passive item. This also includes their upgraded levels, because if you don't do so, you will just encounter a null reference exception. Okay, before testing, let's add two checks in the inventory manager. So we want to ensure that the weapon or the passive item has a non-null next level prefab. So what this means is, if it is null, it means that either there's no next level or we haven't set it yet. Now, before we start playing, we need to create some UI elements to manually level up our weapons and passive items. Here's how we can do it. Firstly, we'll create a canvas. And afterwards, we add 4 buttons to the canvas. Level up knife, level up garlic, level up spinach, and level up wings. Afterwards, also set the text of each button to match its name. And finally, let's space the buttons evenly at the bottom of the canvas. So don't worry about making this look pretty, as we'll delete it later. And once you're done, you should have something similar to this. Now, we need to add an on-click event to all buttons. Select all buttons and create a new event. Now drag the player object into the on-click event and assign the level up weapon method to the knife and the garlic buttons, and the level up passive item method to the spinach and the wings button. In each button, set the index for the corresponding weapon or passive item slot. For example, if the knife is the first weapon, its index should be set to 0, meaning that if you are choosing the knife at the start from the menu scene, this index should be set to 0. Now, if your setup is identical to mine, the indexes for each weapon and passive item should be as follows. Knife will be 0, so just leave the button as it is. Garlic will be 1. Wings will be 0, and spinach will be 1. And now with the UI set up, we're ready to start testing the leveling system. Press any button to level up a weapon or passive item, then check the inspector to see that it has indeed leveled up. You should also see the new upgraded weapon or passive item under the player object in the hierarchy. Test the upgraded effects by moving around in the game, just to make sure that it works. And before ending the session, let's also press a weapon or passive item button twice. Now, you should receive an error message indicating that our checks are working as intended. Awesome! We've now reached the final section of this part, which is to create UI for the inventory. Firstly, let's set up the UI in our game scene to match the grid-based layout of Vampire Survivors. First, create an empty game object named inventory slots under the canvas and set its anchor and position to the top left. Next, you're going to want to add an image under the object and rename it to slot 1 weapon. Afterwards, let's duplicate this 11 times and rename them all so that we have 6 slots for weapons and 6 slots for passive items. And your hierarchy should look something like this. Add a grid-based layout component to the inventory slots object and set the following properties to replicate my settings. This should now sort your UI images in a way that resembles Vampire Survivors. Do make sure to confirm that the top row contains all weapon slots and the bottom row contains all passive item slots. Moving on to the code, we will follow the same principles we used in the inventory thus far. Start by opening your weapon scriptable object script and creating a new field for a sprite called icon. We will use a sprite instead of an image, as we will be changing the image.sprite property and not the image itself. Now, as with the level, this field should not be modified during runtime. Proceed to do the same for the passive item scriptable object script as well. On to the next step. We'll be updating the inventory manager script to handle the UI for the inventory. First, we need to add the Unity Engine.ui library because it handles all things UI. Next, we'll add two lists, one for the weapon slots and another one for the passive item slots. Now these lists will then hold the images that we created in the scene and serve as a reference for us to easily set the weapon/passive item icons. Now in the add weapon and add passive item methods, we simply set the sprite of the weapon or passive item to the image component of the slot index element of the weapon UI slots/passive item UI slots list. So we don't have to do the same for the level up methods, as the upgraded weapon should replace the old one. However, if you do plan to make any changes to the icon when the weapon reaches a certain level, let's say once it reaches the max level it will change its visuals, then yeah, you can do so. So once you're done, head back into the editor, and before testing the changes, make sure to assign the icons of the weapons and passive items in their scriptable objects. Make sure you assign the icons for all levels, so that includes the level 2 as well, for the weapons and scriptable objects. For the passive items, I'll be using weapon sprite sheet _26 for the wings and weapon sprite sheet _62 for the spinach, as they look the most appropriate for their names. However, feel free to just use whatever you want. If you find a new sprite that you like, just use that instead, because there shouldn't be any implication. After assigning the icons, we need to drag all the UI slots to their respective fields in the editor. And once that's done, we can hit play from the menu scene to see if the weapons and passive items icons displayed on the top left of the screen show up. They should also be sorted based on the order they were added, which is left to right. Before wrapping up, let's make one more improvement. Currently, the white boxes of the images are shown even when they are not in use, which can be rather bothersome and it looks kinda untidy. So to fix this, let's add a code snippet to disable the images that are not in use and only enable them when needed. This will result in a cleaner and more organized inventory UI. Okay, so by enabling the image component only when necessary, we can get rid of the annoying white boxes on the unused UI slots. And once you've added the code, go back into the editor and disable all image components on each UI slot. If you're still wondering why we're disabling the component and not the object, it's because the grid layout group will reorganize objects based on which is active. And so if we disable the entire UI slot, so the object itself, it will mess with the position of the slots. That means some of the passive items might show up on top and some of the weapons itself might show up below, which is not what we want. So it's worth noting that you could also add a start function in the inventory manager and a for each loop inside to disable all the UI slots image components while on start. So this will ensure that the UI slots start in a disabled state before being enabled when a weapon or passive item is added. However, since this isn't necessary, I won't be covering it, but feel free to do so. Now, hit play from the menu scene and see the inventory UI in action. You'll notice that the UI is much cleaner and only shows the icons of the weapons and passive items that are in use. Great! That's all for this part. In this part, we went through how to create passive items and a way to manage the player's inventory. This included a way for the player to control and keep track of their existing passive items and weapons. We also created functionality for weapons and passive items to level up. I hope you all enjoyed the video, and if you want to support what we do, you can actually help us by becoming a Patreon. This will give you access to the project files for tutorials, like this one, as well as any Patreon exclusive posts on our blog. You can find the link to this in the description below. Any support that you give us will actually go a long way, because currently we are making back about 20 cents for every single dollar that we put into content creation. So your help will actually go a long way to help us make this a sustainable endeavor. So that's all. I'll see you all in the next part. Bye!